Hi everybody and welcome to this video lesson in Arduino microcontrollers. Today we're going to be working with an HC-SR04, also known as the ultrasonic sensor. Now the ultrasonic sensor is pretty cool because what it's doing is it's shooting out a frequency and then it's waiting to hear the echo of that frequency bouncing back. So it shoots out the sound wave and then it's waiting to hear the sound wave bounce back. And then we can calculate distance based off of that. And we're learning this in regards to eventually trying to create an autonomous robot. So think of like a robot vacuum or a Roomba, right? So it can move forward and it senses if there's items or obstacles, I should say, in front of it, and it can make decisions on what to do based off of that. Our design is going to be very rudimentary when we make ours. It's just going to see if there's something in front of it and make a turn based off of that or back up, depending on the distance. Now, before we can do any of that cool stuff, we actually need to learn how it works. So I've gone through, opened up a new sketch, and I've deleted everything, and we need to set two constant integers, one for our trigger pin, and one for our echo pin, right? So on the... Sorry, trying to type and talk at the same time is a little harder than it looks. On the HC-SR04 ultrasonic sensor, you have two pins in the middle, the ultrasonic or the trigger pin and the echo pin. So they're two separate things that we are now coding out that we can operate with. So once we have those integers put in place, we need to use what's called a float command. This allows for a floating decimal point, meaning that there's a level of accuracy to it, but not so much, and we're not stuck at like 2 decimal points. It can go out to 6 or 7 on the Arduino. Now, it's important to note that the Arduino itself isn't very good with floating decimal points. There are better devices out there if you are interested in using that to get more precision, such as a Raspberry Pi, especially using Python for that. All right, now that we have float, I did float, duration, and distance, essentially setting up two integers that we're going to be able to manipulate in our code. Once you have those in place, go ahead and type in your void setup. And your void setup is going to need you to set two pin modes. Pin mode for trigger pin, and our trigger pin is going to be an output device. So we type in output. Then our second pin mode is going to be for our echo pin, and that's going to be an input device. All right, and make sure that these are corresponding with your constant integers you set up here. And next we need to enable the serial monitor, or serial, so we'll go serial.begin, and we're going to set a baud rate of 9600. Okay, make sure you are adding those semicolons, and now we can exit out of our void setup. Please do make sure that you are putting an end curly bracket at the end or moving past the end curly bracket there. And we'll go into void loop, start parenthesis, end parenthesis, start curly bracket, and hit enter. Here we need to enable our trigger pin to be set as off when it starts up. So we'll do a digital write command just to make it easier for us. So digital write trig pin, and we're going to set that to off, also known as low when we're writing that out. Then we're going to use a new delay command. So normally our delay is in milliseconds, right? So 1000 equals 1 second. Well, now we're going to be using microseconds because we want really, really, really fast input or readings from our Arduino. So we're going to type in a delay microseconds. And it's important you do capitalize the M in microseconds. And we're going to set that to 2 microseconds. Then we'll do another digital write. And we're going to set our trigger pin to on. So it's going to send out the burst. So we type in high. And we'll do a delay microseconds of 10 on that. There we go. And then we'll set it back to being off. So we'll do digital write trig pin is low. Next, I'm just going to scroll down, and I'm going to make some more room so you can easily see this on the screen here. Next, we're going to kind of start writing the equation we need to figure out to get the distance in centimeters for us. So the first thing we need to do is set a duration. So we'll do duration equal sign, or duration is pulse in. So pulse in, and then echo pin. We're going to write that to being on. So duration is pulse in, and pulse in is the echo pin on. Next, we need to calculate the distance from that. So we'll go distance is the duration. Yep. Sorry, that needs to be in parentheses there. Duration times, and we're using the little star, so that's usually shift 8. Right, so duration times 0.0343, parentheses, in parentheses there, and then we'll do /2. So essentially what we're saying is, in this equation, our distance is, or equals, the duration times 0.0343 divided by 2. Once we have that, we can then go serial.print, and then start parentheses, and then start quotation mark, and we'll go distance, and then end parentheses, or end quotation mark you should have, and then end parentheses, then semicolon, and then we'll do a serial.print line, so print ln, and then we are printing distance. So we'll print the distance there, and then we are going to do a delay of 100 milliseconds. And that's it for the code. Now, setting this up is actually pretty easy. Let me jump on over to Tinkercad so you can see what that wiring schematic looks like. Alright, so just kidding on the Tinkercad portion here. As you can see, their ultrasonic sensor is a little different. So what I've done is I've pulled up a very similar looking one, and we can just take a look at that over here. Yep, we'll go here, and let's just open image in new tab so we can take a look at that better. Right, so in their version on this one, they have it on 12 and 11. However, remember ours is written onto 9 and 10 for trigger pin. So in this case, we'd want to make sure this trigger pin would go into 9 here. This echo pin goes into 10 here. But very simple setup. VCC always goes into your 5 volt, just as a heads up whenever you're working with any sensor. Then of course ground goes into there. Very easy to set up your ultrasonic sensor, and it's kind of fun to play around with. Our next lesson, we're going to then attach a buzzer to it so we can make essentially almost like a little alarm system or a beep system if it gets too close to something. All right, if you have any questions and you're watching this for class, you can drop those questions in Classroom underneath this video, or you can always leave your comments or questions in the comment section below if you're watching this on YouTube. And hey, thanks for watching.